Hello everyone, today our topic is addition reaction of Grignard reagent. So the first reaction we do, we add nitrile part in to the Grignard. So CN is a nitrile group. In IUPAC system, we call it alkane nitrile. The compound form RCN is alkane nitrile. And in common system, we call it alkyl cyanide. Let's understand this with the help of a simple example here. I am taking CH3CN. When you call it alkane nitrile, then you add on this carbon in word root part. So here we are having two carbons. So the word root here, it should be ethane nitrile. But in case of common system, we do not count cyanide carbon in a word root part like CH3CN. So only count CH3 carbon. So it should be methyl cyanide. Let's take one more example, like I'm writing here CH3CH2CN. In IUPAC system, we count all the three carbons and it should be propane nitrile as three carbons are here. And in common system, we just count these two carbons only and do not count the cyanide carbon. So in common system, we call it ethyl cyanide. Next reaction, we do addition of Grignard reagent to carbon dioxide. Carbon dioxide, if you draw the linear structure of carbon dioxide, then the bond between carbon and oxygen is polar because of the shifting of pi electron toward the electronegative oxygen towards, and this result in a polarization of bond. So this carbon, it is the electrophilic center here. So it acts as an electrophile. Let's do a general reaction where we add nitrile to the Grignard reagent. Grignard is RMgX, where magnesium is positively charged and alkyl and halogens are negatively charged. To this, we are adding nitrile, RCN. Triple bond is between carbon and nitrogen. Here, as nitrogen is more electron negative than carbon, so this result in the polarization of bond. Here, carbon it becomes positively charged and nitrogen it becomes negatively charged. So, addition reaction of Grignard. The reagent we use is a diethyl ether. When we add Grignard to this nitrile, the negative part get attached with the positive one and the positive part attached with the negative. Like you just see nitrogen is negatively charged. So what we do? We add MgX part with it. Carbon is positively charged. So we add on R minus part with it. Then the next step is hydrolysis. H3O positive. This result in the formation of RC double bond and pink alkyl part is from Grignard. So NMgX, that one is replaced by O here. So what we have concluded from here, nitriles changes into ketone with the help of Grignard reagents. This one is your conversion tips. Whenever you wish to convert nitriles to carbonyl part, ketonic part, then we always do this with the help of a Grignard reagent. Let's understand this with the help of a simple example how nitrile groups are added with Grignard. In both cases, I am taking the methyl part only. So this result in the formation of reaction intermediate CH3C double bond N and MgBr with nitrogen and methyl part with the carbon. On hydrolysis, it results in the formation of ketone CH3C CH3 and double bond O. So this one is a conversion where we converted ethane nitrile into acetone, propanone, you can say. Let's take one more example. CH3CN with, in place of methyl, now I am taking ethyl here. So with ethyl magnesium bromide, this result in a formation of reaction intermediate CH3C double bond N MgBr with nitrogen and ethyl part with the carbon. And this reaction intermediate on hydrolysis gives a ketone CH3C double bond C and O. So here we are having blue part, oxygen part from the water, black alkyls are from Grignard reagent, and the greenish part is from the nitrile. So this one is a conversion where we converted ethane nitrile into 1, 2, 3, 4. So it is butanone. Let us do one more conversion for better understanding of the concept. Now I am taking propane nitrile, or you can call it ethyl cyanide with isopropyl magnesium bromide. Here I am having. So this gives an addition product C carbon double bond N MgBr with nitrogen and isopropyl part with the carbon. And this compound on hydrolysis, it produces the required ketone. So we name it 1, 2, 3, 4, 5. So this one is a conversion where we converted propane nitrile, or in common system you can call it ethyl cyanide. So this ethyl cyanide, with the help of Grignard reagent, we converted into 2-methyl, 5 carbons are here, pentane 3 on. In each and every case, byproducts are ammonia and MgOH-Br. Now let's take one more example where I'm taking benzene ring. So here it is CN. This one is benzonitrile. We can call it cyanobenzene. So this benzonitrile, I'm adding CH3 MgBr here in the presence of ether. Product obtained in this case, we have nitrogen, it get attached with the MgBr part and carbon with the CH3 part. The resulting intermediate get hydrolyzed to give it is acetophenone. So here the conversion is benzonitrile. That one get converted into acetophenone with the help of Grignard reagent. This benzophenyl, it is also known as cyanobenzene. Let's take one more example of benzonitrile I'm having, and to this I'm adding ethyl magnesium bromide, and which result in the formation of reaction intermediate, and the resulting reaction intermediate on hydrolysis gives a ketone. So N get attached with the MgBr part and carbon with ethyl. The resulting reaction intermediate on hydrolysis, it gives ketone. Let's name it 1, 2, 3. So this one is a conversion where we converted benzonitrile into 1-phenyl propionephenone. Now let's discuss addition reaction of Grignard reagent with carbon dioxide part. So in this case, the intermediate part formed is carbon. It becomes positively charged, act as an electrophilic center here. So this result in the formation of R. R is negative, which get attached with the carbon. COO. MgX part is positive, it get attached with the oxygen. This reaction intermediate on hydrolysis, it gives carboxylic acid. Reddish part is from a carbon dioxide, R black part is from Grignard, and H bluish part is from water. So in order to convert alkyl or aryl magnesium halide into carboxylic acid, we use these steps. Let's understand addition of Grignard reagent to the carbon dioxide with the help of a simple example. Here I am taking CH3 MgBr. It react with carbon dioxide in the presence of ether, result in the formation of reaction intermediate where carbon it get attached with the alkyl part and oxygen it get attached with the magnesium bromide part. This reaction intermediate on hydrolysis, it produces carboxylic acid. So by this way we convert methyl magnesium bromide into acetic acid, a common name for ethanoic acid. For better understanding, let's take one more example here. I'm taking phenyl magnesium bromide, and to this I am adding carbon dioxide. This result in a formation of reaction intermediate COO MgBr. This reaction intermediate on hydrolysis, it gives benzoic acid. So a conversion where we converted phenyl magnesium bromide into benzoic acid. Let's do a quick revision of all Grignard reaction. So RX with Mg, it forms alkyl magnesium halide, which is a Grignard reagent and is a rich source of carbanion. This Grignard reagent in presence of H plus, rather that one comes from water you can take, or it comes from ROH alcohol I have here, or from carboxylic acid you can take like NH3, means any of a compound which gives H plus that changes this alkyl magnesium halide into a hydrocarbon part. Next part, RMGX with methanol, simplest aldehyde, it gives primary alcohol. It changes into primary alcohol in the presence of Grignard reagent. So primary alcohol is CH2OH, and this primary alcohol with copper at 573 Kelvin, it changes into aldehyde part. Next, higher aldehyde. Here I am taking R prime CHO higher aldehyde with Grignard reagent produces secondary alcohol. Functionality part of secondary alcohol is CHOH, and these secondary alcohols with copper at 573, that is on dehydrogenation, changes into ketone. Ketones CH3 COCH3 with Grignard reagent, they changes into tertiary alcohol. Tertiary alcohol is carbon surrounded by 3 alkyls. Grignard reagent with nitriles gives ketone. And last, Grignard reagent with carbon dioxide produces carboxylic acid.